5, it says that after a checkup, you leave a physician's office where you weigh 683 newtons. And then you get into an elevator that has a scale. And then it wants you to find the direction and magnitude of the elevator's acceleration if the scale reads A, 725 newtons, or B, 595 newtons. So for the first part here, you want to find the mass of yourself, I guess. So to do that, you get force equals mass times acceleration. So this is your weight, which is a force. So you divide that by the acceleration of Earth. So you get 6. You get 683 divided 9.81, and that comes out to be, what's it, roughly 69.6 kilograms. And then use the same force equals mass times acceleration here to figure out the acceleration from both. So you take the force here divided by the mass, which you just calculated up here, and that'll give you the acceleration. So when you do that over here, this one comes out to be 10.4 meters per second squared, and this one comes out to be 8.5 meters per second squared. That's roughly. But these are the total acceleration acting on the person. So this equals the gravity, the acceleration due to gravity, plus the acceleration of the elevator, which I'm going to call E because elevators. So to get the actual acceleration from each of these, you just subtract out the G, and that will give you 0.603 here. And then for this one, it will give you 1.26 meters per second squared. And then to find out what direction it is, it's pretty easy. You just look at the numbers you have here. This one is greater than the force of gravity, which is 9.81 meters per second squared. So since it's greater, that means that it's adding together, so they're acting in the same direction, which means that this one is in the upward direction, because if you're accelerating something upwards, you have to apply a greater force on it. And then since this one is smaller, that means you're going down because it's reducing the force of gravity by accelerating you downwards.